Good evening, everyone. Welcome to your Thursday evening stroll around your celestial neighborhood. Super excited to be here and have a few people tuning in. I know I'm really bad. I forgot to post about this because, one of those things. Anywho, um, really excited to talk just a little bit about some spacecraft tonight, the little spacecraft that could hopefully yeah, so we're going to be focusing on Pioneers tonight, Pioneers 10 and 11. I guess mostly 10, but we'll see what all we get to. And really, again, flying by the seat of my pants like I do, because, time and things, and who needs practice when you've got open space that has all the magic buttons for you. So we'll be using same visuals as always, Stellarium, which you can find at stellarium.org, and OpenSpace, which you can find and download for free at openspaceproject.com. And I did update to a newer one to get my models in here tonight, but I believe an even newer version is coming out very soon. So again, if you're running OpenSpace, check that out. I know I don't update nearly often enough, but I'm expecting, I think it's 16.2 out real soon here. So we'll pop on over to Stellarium. Instead of blabbering on about all the awesome software, we'll actually look at it. So Stellarium, we have our beautiful Brooklyn sunset happening. And what did I want to look at in the sky tonight? Oh yeah, the sky. Just the sky is pretty nice. So we're going to fast forward just a smidge. Again, if you're in New York, Manhattan Henge is still happening, and that will still be happening for the next almost month. I think it ends on, well, I know it ends on July 12th. I always remember because it's my mom's birthday. So I have to remember that one. But yeah, we have some planets out. And actually, I wanted to talk just a little bit about Mars. So Venus is great. So check out Venus because it's bright and pretty, and it's going to be getting higher and higher for basically the rest of the year. I think it reaches its greatest eastern elongation in December or something. It takes, forever because it's, I know, kind of similar. And anyway, it takes a while for it to go back and forth. Not like Mercury. Mercury's like every other month zipping back and forth. So Venus is out there, bright-ish. And then Mars is a bit above it. And Mars has been getting dimmer and dimmer. I think one of the last times I saw Mars in the sky, I hadn't seen it in a while. And I was looking and I picked out Castor and Pollux. And I was like, wow, Mars is even dimmer. So if you look at with Stellarium, we can see the magnitude of Mars is about 1.8 right now, whereas Castor and Pollux are more like 1.1. So 1.1, 1.9. Okay, a little bit dimmer. Sorry, Castor. But anyway, yeah, so Mars is getting fainter and fainter, but it's doing a really exciting thing this next week. Well, it's, just moving the way it does, but in the next few days, so I think it starts, I wrote down the 20th, but really I think it's more like the 21st or 22nd. So early next week, we're going to go ahead and fast forward to the 22nd and make this a little bit darker. So it's going to be kind of tricky because Mars is going to be closer to the horizon. I think it's going to be about 10 degrees above the horizon as it's getting kind of dark enough to see this other stuff that I want to look at. But yeah, if you see Mars, next week, basically Tuesday, Wednesday, Thursday, if you can see it in binoculars or a telescope, it's going to be right in front of this open cluster, the Beehive cluster. So that's a Messier object M44, this big open cluster, relatively close to us. I want to say about 500-ish light years away, 400 or 500-ish light years away. And yeah, so very open. So a bunch of young stars. It is an open cluster and clearly visible with the naked eye in a dark sky. But from more light polluted areas with somewhat light polluted areas, you can see it in telescope or binoculars. So the best view, of course, is going to be on the 23rd when Mars is right in there with all the little bees buzzing around if you use your imagination. And then the 24th, it's kind of moving off to the side. So the 22nd, 23rd, 24th, weather is always an issue, but really the 23rd, so I think that's next Wednesday evening, will be the best day to see Mars right in front of an open cluster. So that's a cluster because it's in the constellation Cancer, which is, obviously along the ecliptic. That's where Mars is passing. So every now and then we get like a really cool like planetary alignment with stuff like right there in the cluster, so to speak. So that's your challenge for this week is try to find Mars. And if you are in a dark site, see if you can pick out that cluster and see them together. And if you're not such a dark site, see if you can pick it out in binoculars anyway, or just, find Mars and see if you can keep track of it as it's getting fainter and fainter. I also wanted to point out that our other planets are out in the evening. You don't have to stay up till like some ungodly hour to see them. Um, Look at that. That's 11. Well, maybe I'm getting ahead of myself. I get confused with the different different forecasts they do. 11 midnight. Okay, yeah, all right. So there's Saturn. Saturn's up before midnight, barely. And in another week or two, Jupiter will be as well. So let's see. Yeah, if you wait till like 1, Jupiter's up also. So they're getting there. So we'll have them in the eastern sky for, much of the summer. Oh yeah, it's summer on Sunday. Yay. So the nights will start getting longer again. Yay. So that was a genuine yay, the second one. So yeah, but yeah, these planets will be rising earlier and earlier. So we will get to have them like featuring more in our evening sky and not, at midnight, which is way past this astronomer's bedtime. Yeah, I know. I almost lost my astronomer card, but I did go see the eclipse, so I managed to hang on to it. Yeah. Yay. So yeah, so solstice. So if there's like an alignment near you, I don't know if you're at Stonehenge or anything henge or like whatever, not Manhattan Henge, that's a different thing. Yeah, check it out, do a little dance, celebrate that the nights are getting longer again. So at least for the northern hemisphere. For the northern hemisphere, that's when the sun is furthest north, and then it'll be moving further south. If you're in the southern hemisphere, um, then it's a little bit different. That will be your winter solstice, and so your nights will start getting shorter. Wah, wah, sorry, but yeah, the eclipse was pretty amazing. Thanks to AAA and some other connections, we got to see it from like a really tall building in Manhattan, and it was a little bit cloudy, but we got to see just a little bit of the horns. So it looked kind of like it did in Stellarium. It looked, let's see, where did we go? We go back 1, 2, 3, 4, 5, 6, 7, and forward a smidge. It was a very early morning. I'm usually up at that hour. But first, I figured out that my phone doesn't really work as far as compasses go. My phone compass is always off, so I had to use someone else's phone compass. And did I get the wrong date? Was it I think I did this. Oh, because that's May, June. Maybe this has already risen. But yeah, it was pretty great. It was kind of cloudy, so other people in slightly different locations had a slightly better view. Um, Now I'm just completely spacing on this. So yeah, we'll just say it was nice. So I hope other people who tried to see it at least got to see something and weren't, blocked by the weather. Oh, right, because I'm looking at today's date. I don't actually know what the day is. Obviously. I feel like I'm living. Oh yeah, there we go. That's more like it. So if we put some landscape in there, yeah, we basically saw it when it was just above the horizon and then it got cloudy, like in that part, because we were looking through a lot of atmosphere. But yeah, there'll be others. There will be others. So never fear. Those planets, they just keep on moving. I think there's one in December. More on that later. So for now, let's pop back on over to open space. And yeah, space always feels good to the open space. Again, so open space, I have this set for 1972. So we can follow the pioneers for a little while. And again, this is all real data, really fun. And some of the things that they have loaded into OpenSpace are different missions. So we have the Pioneer mission, we have the Voyagers, we have a whole bunch of other fun things. But for this one, I'm just using some of the Pioneer assets. So they show like trails and stuff for the Pioneers. So right now we're in March of 1972. So the Pioneers, actually, I wanted to turn on our orbits for a bit and zoom out a smidge. Um, Oops, yeah, so you can see a little bit of the moon's orbit. So the concept for the Pioneers, I think, was first started like in the late 1960s, 1969-ish. We were doing other cool things, landing on the moon, pretty awesome. We'd had like the Mariner programs had been running through the 60s and also ran into the 70s. And so we had explored, as a species, we had explored all the way out to Mars, right? I think that's Mars there. Yeah. So all the way out to there, right? So there's a whole bunch of solar system that we hadn't even touched, like not even. I mean, we'd seen light, we had telescopes, obviously. Um, but we'd been into the inner planets, we've been all the way out to Mars. Nothing wrong with the other terrestrial planets, but there's still just a whole lot of the rest of the solar system to explore. There's the asteroid belt, there's the gas giants, there's what we now call the ice giants, which of course the pioneers didn't reach. That didn't happen until the Voyagers came along a little bit later. But yeah, the idea behind the pioneers was to be like, all right, let's get out past Mars. We're getting really good at this inner solar system. Just keep pushing our limits, and go out and see Jupiter and Saturn, like in real life. So we did. So 1972, the Pioneer 10 was launched. 11 was launched just over a year later in 73, in April of 73. But I just want to see if I can do time things correctly. Um, I just poke this out a bit, so we'll fast forward a smidge. Hopefully, not break anything, and go ahead and focus on Pioneer and just take a quick look at it. So if we zoom into that, yeah, so you can see the trail there from its launch. So I fast forwarded to like a month after launch. So they were both launched on, what did I write down? Atlas Centaurs, which apparently had, enforced some kind of weight limit. So they're both right around 570 kilograms, pounds. I think one was 569, the other was 570. So basically all the same stuff. Pioneer 11 did have one extra instrument that Pioneer 10 didn't. But yeah, I feel like I've done a thing about Voyagers, partly because I taught a class about it. Hey, Chris was in. Hey, Chris. um, but yeah, so it's same kind of format if you're familiar with the Voyagers. And actually, I guess, Voyagers came later, so they kind of model the Voyagers a little bit after this. But you have like kind of your bus that has like a whole bunch of sides and all of this instrumentation and everything, and then you have your huge communications dish. And I believe this is probably the magnetometer bit, because you need like just a long line for that. And then I think these are the booms. They had 10-foot booms that they put um the the power sources, the RTGs. So those are the radioisotope thermoelectric generators. So there were two on each boom. So they stuck them out on these 10-foot booms, just to keep them away from all the electronics on the main bus. So all that stuff that's on there, as well as the plate, which we'll talk about. But yeah, so all kinds of instrumentation that they had on there, stuff to detect magnetic fields, stuff to detect and analyze the solar wind, some imaging, even some things to detect and help do like tracking of meteoroids and small asteroids, because we hadn't even been to the asteroid belt, right? So again, that's past the Mars thing. Um, So yeah, so they kind of packed like a whole bunch of instruments on like you would. The one extra instrument that Pioneer 11 had that apparently 10 did not was fluxgate magnetometer. So again, that was just for measuring the magnetic fields of Jupiter and Saturn. And I just have to say that the imaging photopolarimeter, um, that was, I guess, built slash based out of U of A, my alma mater. So, so just leaving that there. But yeah, so these RTGs, um, the radioisotope thermoelectric generators, those were kind of a new thing, I guess. People were a little nervous about, putting it on top of a rocket back in those days, understandably. Um, and so yeah, so that was a little bit of an issue, but this was like a newer brand of these or something. It did have, plutonium in there that was basically giving off heat to, generate the energy. But yeah, anyway, so it worked more or less. More on that in a little bit. So we're gonna zoom out a smidgen here and just see, yeah, where we went with these. So again, so the first one, so we're just kind of following along. This is Pioneer 10, again, launched in early March 2nd, 1972. Um, and I think one of the sources said that as it moved past the moon, it was the fastest moving man-made object at the time, fastest human-made object at the time. Um, but yeah, let's just zoom out, and I like following these things through their flybys because it's just kind of awesome. If I can, you zooming? Yeah, we're zooming ever so slowly. Zooming. All right. So it didn't go to Mars, right? It didn't go past Mars, but it took just a couple months to get to the path of Mars, right? So even today, like it takes about 6 months or so to get to Mars. So I'm just going to kind of zoom this out a little bit, and then we're going to click through time. So April, we're already a month in. May, and in June, it basically crossed where the orbit of Mars would be, right? So we're already like out to Mars distance. Um, a month later, July, it reaches basically the asteroid belt, or what they were calling the asteroid belt. Um, so the asteroid belt is kind of big, right? So if we look at, talking about distances within the solar system, we measure the Earth-Sun distance, right? That's one astronomical unit. So it's about 93 million miles or 150 million kilometers. So Mars is about 1.5 times that distance. So it's about 1.5 AU. And then the largest bit of the asteroid belt is around, I want to say 2.5, if I'm not just making up numbers here. And Jupiter's out around 5, right? So this is kind of a ways out here. So if we just kind of keep zipping through time, so it reaches the asteroid belt um, in, we'll say, July 1972. And it wasn't until over a year later, December 1973, that it actually gets to Jupiter. So a couple of things are happening here. One, the solar system is big. The outer planets are really far away. So like the inner planets are kind of crammed together compared to the outer solar system. And then also, it can be losing a little bit of speed, right? So it's trying to get away from the sun at this point. It's away from Earth, but still moving away from the sun. The sun is pulling on it gravitationally. But it gets a little bit of a kick, a little bit of a slingshot as it comes past Jupiter, which we should check out. Nice up close and personal like. So yeah, so the speed changes quite a bit, and with these kind of deep space missions, right? They get an initial kick from their rockets. Thank you, rocket. And then here, let me just pick a faster time to go through. Bit faster. And then they get kind of these slingshots when they go by the planets. So they get kind of a gravity assist. So really, you can use a planet to help you speed up or slow down. Pretty sure we were speeding up at this point, again, just to try to reach, just to try to um, escape the sun, escape the solar system. So this was going to be the first mission really to escape the sun's gravity. I'm looking around and I feel like I should see Jupiter by now. If anybody sees Jupiter, just holler, just point to it. Oh, there we go. Thanks. All right. So I'm going to fast forward, see if I can move through time a little bit faster here. Yeah, there we're going. Um, so yeah, so we had like nice pictures and stuff of Jupiter, but we didn't have like anything up close and personal of Jupiter or its moon. So we got like a little bit of snippets, did some flybys, came close-ish to some of the moons, but got kind of a sense of the magnetic field, and it was sending back lots and lots of images. So I mean, these were like, again, 1970s computers. Um, so not the fastest things, not like what you have on your phone, nothing compared to what you have in your pocket right now, basically. Um, but wow, it's so pretty. But yeah, it got pretty close to Jupiter. I think, did I write down maximum speed? Of course not. Oh yeah, I did. 132,000 kilometers per hour. Um, so yeah, fast. So you can just see like just how close to kind of the cloud tops it comes, um, as it passes behind Jupiter in its orbit to get that extra kick. And whoo, there we go. Thanks, Jupiter. Thanks for that little tug there. And then, yeah, then basically off to Saturn. So that was again December 1973. So think about what you were doing in 1973, if anything at all. And then, oh yeah, just kidding. This one didn't go to Saturn. That was it. So it actually got a little kick, and that was it. I was off out into the solar system, or out of the solar system. So kind of going up above the plane, I believe. The same thing happened with the Voyagers. They sent them basically in opposite directions from the plane of the solar system. But yeah, off it goes. So the next flyby then I guess that we can check out is the Pioneer 11. So that one did, if we focus on Pioneer 11, here comes Pioneer 11, and we just did a Jupiter flyby, so we won't do that one again, but we'll just kind of pop through time. So again, this one launched a little over a year after Pioneer 10. So if we see, it took about the same time for Pioneer 11 to get out to about to Jupiter. So it gets there, almost a year after Pioneer 11 did, or sorry, a year after Pioneer 10 did. So here comes Pioneer 11. That was November 3rd, 1974. Yeah. So let me just click through our thing. So early November 1974. So, and it kind of looks like Pioneer 10 is still pretty close, but remember it's like kind of kicked up off the plane of the solar system here. So if we look in the plane, we can see that it's actually, yeah, heading up. Not sure how bright some of these lines stick out, but yeah, so here we can see like the plane of the solar system along here, and then the path of Pioneer 10 going just a little bit up above it. If we consider north up, which if we use the right hand rule, that's kind of what we do. Didn't realize the right hand rule kind of applies to orbits and things. That's how we define north. Who knew? I don't know. Anywho, yeah. So November 74, we are. That was our Jupiter. And then it's a little ways out to Saturn. So remember I was talking about like the distance out to Jupiter, and I know I should have all these memorized, but for some reason I don't. So it takes even longer to get out to Saturn. Also, you'll notice it took a little bit shorter of a time for Pioneer 11 to reach Jupiter than Pioneer 10. So again, just orbital mechanics. There's kind of a window of time in which you can launch from Earth and get to Jupiter in a relatively short period of time. So that happens like every 13 months or so. So if they wanted to catch the window, they launched them both within that same window. So they just had slightly different travel times. But yeah, so 74, and then it takes a couple years. So here we are so it gets a kick from Jupiter. That's an interesting kick. I didn't realize it looked like that. And slingshotting over towards Saturn. And it gets to Saturn. Oh, it seems like it's almost there, but it's really not. Because we're only in 1978. So it doesn't actually get to Saturn until the end of July in 1979. What were you doing in July 1979? Anything? Um, yeah. So let's check out our Saturn flyby because this is the last flyby, right? So they didn't go to the outermost planets, but these again were the first missions to check out the gas giants. So the first things to go whiz bang by the Jupiter and the Saturn. So you can zoom in here and actually see the instrument. And again, it's the same model because they're, pretty much twinsies. Um, and yeah, we'll just play through a couple of days here and then play through time a bit. Am I playing time? Playing time. All right. And again, if anyone can see Saturn, let me know. Try to find Saturn in the window. I think it's not in the direction that we came. So try to look away from the trail. And I think I'm going in the wrong direction. I think I'm a little bit uh orientations. Do we miss Saturn? Oh wait, nope. Nope. Oh, I think it's gonna be the end of this line. I feel bad to lose a planet. I mean, it's kind of big thing. Okay, there we go. There's our Saturn. Um, so yeah, so Saturn and all its planets. Um, and so we're good. So we can speed this up a smidge. Let me take us through a few more days here. I just like doing the planet flybys, mainly because we can. Um, 28. Okay. So we'll just sit past here. Um, yeah. So, I mean, at this point, it's practically the 80s, and computers have changed a bit. But at this point, they're what over well, not quite 10 years. If I can do math in my head, um, 7 years, over 7 years into the mission, um, and technology is just zipping along. Let's go a little faster here. Um, so they kept the technology sitting around in some room, like you do. Even as technology was advancing, they had to kind of just keep big honking, this big honking computer, uh, taking up space in the room to communicate with these. Um, yeah, not so much disco, not quite an IBM yet. um, but yeah, just bopping along there. They did have, so I know I mentioned that it has this huge, disk here. I don't know why did I miss something? Did we miss Saturn? I think I missed something because we should have flown by Saturn by now. Because now we're in August. Um, maybe I wrote something down totally wrong. Maybe I wrote down the wrong year. Anyway, I may have written down I wrote down July 31, 1979. It looks like I got that totally wrong. Maybe it was August 31, 1979. Oh, if only I knew numbers. Um, Yeah, this looks better. Oh, but yeah, so they did have the Deep Space Network, the NASA Deep Space Network that they've been using to communicate with other deep space missions, other things that we've sent out to like far, far away places like the other terrestrial planets. So the NASA Deep Space Network has huge radio dishes for communications in three little corners of the world pointed in different directions. So you basically get full coverage if you're, out beyond like somewhere it's even within um, I think the full coverage extends, down to, I don't know, some distance. It's a fraction of the distance between the Earth and the Moon. So if you're more than that distance away, you have full coverage. So we have one in Spain, one in Australia, and one in California. I should specify, Eastern Australia, near Canberra. So oh, Saturn flyby. Oh, the rings. Look at that. So collecting, I don't know if they collected like any meteoroids, any whatnot from the rings. But again, studying Saturn's magnetic field because that had never been done before. And it gets a little kick so it can go on its merry way. So it looks like it went, this might make a liar out to be over kind of the north side. So it's going to head southward out of the solar system. The other thing just to note, since I was talking about micrometeoroids, I forgot to mention earlier, we hadn't really sent anything through the asteroid belt before. So this was also, I believe, before Star Wars, because I never actually saw it in theater, so I have no idea when it came out, just, before 1990. Anywho, don't judge. But asteroid belts and asteroid fields are, well, the asteroid belt is nothing like you see the asteroid fields that you see in movies. So it was like anything, pretty small actually would have completely damaged these probes, and that would have been a huge, huge issue. Fortunately, that didn't happen, and it's a whole lot of space between the asteroids and the asteroid belt. So they got through just fine, all intact. However, as we're still zipping through time. And I'm just going to kind of pause time. I don't know if that helps with the lag or not. Um, Wanted to make a note. Yeah, so their signals. Remember those four RTGs that they use for power? They don't last forever. Clearly, nothing lasts forever. Ever. Can kind of want to look at these kind of face on and see where these are um, today. So actually 11, which was a little bit newer, right? Because it launched later. That one gave out before 10 did. So the batteries, so to speak, the power from Pioneer 11, that basically tapered out circa 1995. So they basically shut that down. It was pretty far out at that point. Let's see if we can kind of zip through time without breaking things. Pioneer 10, that signal became too faint, was getting really, really faint, basically around 2002. So the batteries were still going, the RTGs were still plodding along, but it was just too far away, too faint. So it wasn't like designed to put out a strong enough signal. So here we are in 1999, right? So Pioneer uh, Pioneer 10, or sorry, Pioneer 11, we've already kind of lost track of over here, I believe. And then 11, we're still tracking through 2002. So the last very faint signal that they were able to detect from it, they got in January of 2003. So that's where they were at that time. So they're still out there. They're still going. They basically have escape velocity. The Voyagers have overtaken, I believe, both of them at this point. Um, so the Voyagers are further away than the Pioneers are now. But the other kind of fascinating thing, like I know I didn't talk about like a lot of the data collection, partly just because I didn't have time to research as much as I would have liked to. The other cool thing that we learned from these, though, is is something about the anisotropic radiation pressure. So there was this thing called the Pioneer anomaly, where the position of the pioneers was off by a little bit. It was about 5,000 kilometers per year that they were like slowing down, and so they weren't traveling as far as fast as we thought they would, based on our understanding of geometry. Even if you take Einstein's relativity, I mean, they knew about relativity in the 70s. Um, but more recently, I think it was in the early 2000s, so less than 15 years ago now, I think, they did some studies to try to figure out exactly what this was, and it turns out that, it was actually heat from the power sources. So even though they were doing a little bit of a barbecue roll, like we did with the Apollos to keep the people from, like overheating on one side, and you get thermal expansion and bad things happen, like your spacecraft busts apart or something. So you don't want that. So you do these little rolls, but there was still some unevenness, and more heat was being given off in one direction than another. So you have this anisotropy, and so that heat being given off, that's a little bit of radiation pressure, and so that actually pushed it a little bit, enough to make it off course by 5,000 kilometers per year. So now that we know these things, the next time we send something out of the solar system, we can take that into account. Woohoo! Not sure if we're doing that anytime soon, but I believe we're going to have another alignment in the next 50 to 100 years to reach the outer planets again. So just saying, fund those, please, because the outer planets are awesome. And I'm a little over time, but thanks for joining in and listening to me babble on about these really awesome, really early, and still kind of going, but not in communication missions. So again, I'm Irene Pease, your friendly neighborhood astronomer, taking you for tours around the solar system and everywhere else you want to go or don't want to go, or wherever I feel like going. If you have requests, please send them in. I'm happy to take requests. For visuals, as usual, we use Stellarium, which you can find at stellarium.org. I have it on my desktop and all my devices. And of course, OpenSpace, which you see in the background now, you can find and download that for free. It's all open source software, and we're always adding new data. We, as in, yeah, I kind of help, but mostly other people do it. You can find that all at openspaceproject.com. Also, again, I just like to remind people that there's a podcast. If you really want to hear my voice even more, you can uh, yeah, you can check out the podcast, and I'll put the links for that in the comments. It's aasky.nyc, and that is the official podcast of the Amateur Astronomers Association of New York. And sorry about the stream rate. It sounds like we've been having a little bit of issues. I'm not sure why there were some issues today, but thanks for sticking around. If you watch the recording, it might be a little bit better if you have, all kinds of time for that. Thanks, everyone. Clear skies. Be safe out there. And if you haven't yet and you can, please go get vaccinated.